What if the silence of the universe isn't emptiness, but a deliberate choice made about us? That is the core question behind the zoo hypothesis, one of the most unsettling proposed answers to the Fermi paradox, and the one that refuses to go away no matter how hard scientists try to dismiss it. In 1950, physicist Enrico Fermi was having lunch at Los Alamos National Laboratory when he asked a question that would haunt science for decades. Where is everybody? The galaxy is ancient. It contains, by one 2013 estimate from researcher Ravi Kumar Kopparapu, somewhere between 95 and 180 billion potentially habitable planets. NASA has confirmed more than 6,000 exoplanets as of 2024, with up to 70 flagged as potentially habitable worlds. The TRAPPIST-1 system alone, just about 40 light-years away, holds 4 planets in its habitable zone. And yet, across all our searches, we have heard nothing that holds up. The silence is not for lack of trying. Since 2016, the Breakthrough Listen project has represented the most comprehensive SETI search in history, scanning across large frequency ranges with multiple major telescopes. Radio searches have long focused on the so-called waterhole, the frequency band between the hydrogen line at 1.42 GHz and hydroxyl emission at around 1.66 GHz, a range considered a natural cosmic meeting point. In 1977, a signal was detected at exactly that hydrogen frequency, strong and narrowband, traced toward the region of globular cluster M55. Researchers called it the WOW signal. It was never heard again. So what explains the silence? Many hypotheses exist, but in 1973, Harvard astrophysicist John Ball, working with MIT's Haystack Observatory, published a paper in the journal Icarus that offered a particular answer. He called it the zoo hypothesis. The idea is direct. Advanced extraterrestrial civilizations know we are here. They have chosen, deliberately, not to contact us. We are being observed, perhaps studied, the way we watch animals in a wildlife reserve, without interference, without revealing ourselves. The silence is not absence. It is a policy. Zeitgeist. That framing should give you pause, because it shifts the entire nature of the problem. The Fermi paradox usually assumes that if intelligence exists, it would spread, signal, or make itself known. The zoo hypothesis says that assumption is wrong, that a sufficiently advanced civilization would understand the risks of contaminating a developing species and would design a perimeter around it. No transmissions in, no landings, no detectable footprint. It is, in a strange way, the most anthropocentric and the least anthropocentric idea at the same time. It says we are special enough to be protected, but not special enough to be contacted. Now here is where the hypothesis gets genuinely interesting, rather than just philosophically provocative. The zoo hypothesis is usually dismissed as untestable and therefore unscientific, but a 2024 research paper challenged that assumption directly. It argued that within roughly 50 years, our detection capabilities will improve to the point where hiding waste heat, the thermal signature of any large-scale technological civilization, becomes functionally impossible. If advanced civilizations exist at galactic scale and are concealing themselves, the physics of thermodynamics will eventually betray them. The hypothesis may not be untestable forever. It may simply be untestable now. That is a different claim, and it matters. But the zoo hypothesis carries serious logical vulnerabilities, and treating it as a real proposal means facing them honestly. The first is coordination. If intelligent life is common across the galaxy, then many independent civilizations would need to agree on a single non-contact policy toward Earth and enforce it without defection. Each civilization would have its own values, its own history, its own motivations. The idea that every one of them independently concluded that watching humans from a distance was the correct approach, and that none broke ranks, strains credibility at scale. One rogue civilization, curious or indifferent to the agreement, should have made contact by now. The second weakness is the Copernican principle. Science has repeatedly shown that Earth does not occupy a special position in the cosmos. We are not at the center of the solar system, not at the center of the galaxy, not in a privileged location in the universe. The zoo hypothesis implicitly requires that we are special enough to warrant a coordinated interstellar non-interference policy. That is a significant assumption to carry. The third weakness is one of the most underappreciated. We have not been passive in this conversation. In 1974, a team including Carl Sagan and Frank Drake transmitted the Arecibo message toward a distant star cluster, a binary encoded signal containing a human stick figure, a diagram of DNA, and a depiction of the telescope that sent it. We announced ourselves. If a zookeeper civilization was watching, they now know we are aware enough to reach outward. And still, nothing. As of early 2026, astronomers have narrowed their focus to 45 Earth-like planets in habitable zones as the strongest candidates for harboring life. A shift from broad discovery towards strategic prioritization. The search is becoming more precise. The targets are becoming more specific. What makes the zoo hypothesis genuinely worth taking seriously is not that it is likely, it is that it is structurally coherent in a way many Fermi Paradox solutions are not. It does not require that life is rare. It does not require catastrophe. It only requires that someone, somewhere, made a decision about us and had the capability to make it stick. The question that remains is whether that is a comforting thought or a deeply unsettling one. If the zoo hypothesis is wrong, we are probably alone in a vast and indifferent universe. If it is right, we are being watched by minds we cannot detect, for reasons we cannot know, under rules we never agreed to. Which of those answers would you actually prefer? If you enjoyed this video, consider subscribing to the channel.